guys, up until this point, we have just used right angle triangles to help us to solve questions involving lengths and angles. But now we're going to see how we can use trig to help us to solve real-life problems. This is the example on page 87. 3 Johannesburg schools which have been shown on our diagram, and it's important to note here the diagram is not drawn to scale. These are shown. So what they've done is they've drawn on the diagram Bryanston High, Greenside High and Soweto High. And what they've said is that if it is calculated that the angle made on the map between Greenside and Soweto High from Bryanston is 43 degrees, so therefore we've got Greenside, we've got Soweto, and then the angle formed between the two schools as measured from Bryanston High is 43 degrees. We need to find the distance BS, which is the distance from Bryanston High to Soweto High. So therefore, based on this diagram that we can draw from all the given information, we will be able to find the distance between these two schools using what we know so far about trig. We are looking for the distance BS, so that's the distance between Bryanston High and Soweto High. We know that the angle formed between Greenside High and Soweto High from Bryanston High is 43 degrees. And we also know that the distance from Bryanston High to Greenside High is 9,2 k's. Therefore, let's label using our triangle, which is our hypotenuse, the adjacent, and the opposite. The side opposite the 90 degrees is the hypotenuse, which is BS. The side adjacent to angle 43 is side BG. And then the side opposite angle B is side GS. So therefore, from this diagram, we can see that we are looking for the hypotenuse, and the side that we are given is the adjacent. So BG over BS, which is adjacent over hypotenuse, would imply that the ratio we are interested in here is cos. So working from angle 43, we can say cos of 43 degrees is equal to the adjacent side, which is 9,2, over the hypotenuse, which is what we are looking for. So therefore, all we've got to do now to solve this is times both sides by BS and then divide both sides by cos 43. So therefore, I will get that BS is equal to 9,2 divided by cos 43. We can then put that into our calculator. So it's 9,2 divided by cos of 43. And that gives us an answer of 12,579 if we round that off to 3 decimal places. And remember, the distance was given to us initially in kilometers, so therefore we can say that this is 12,579 kms, or since the original distance was given to 1 decimal place, we can say that this is approximately 12,6 kilometers. We're going to move on now, still using trig to help us to solve real-life problems. This is the next example on page 88. Here we are told that an aeroplane takes off at Durban International Airport and it makes an angle of 34 degrees with the ground. So let's have a quick look at our diagram. Here we have Durban Airport, and we see that the angle that the aeroplane makes with the ground is 34 degrees. We are then told if the aeroplane continues to fly at this angle being 34 degrees, for 20 k's more, at which time it will be directly above Umhlanga. We then have to work out how high it is above the ground. So it travels at an angle of 34 degrees for 20 k's, which is what we've represented as the distance from Durban Airport, and then its height above the ground, where it's somewhere above Umhlanga. So what we need to work out in part 1 is how high it is at that point. So therefore, now that we've represented all of our given information on the diagram, you know that this distance is what we are looking for, and this will be a perpendicular distance to the aeroplane in the sky. right? So that's a perpendicular distance, so therefore we can say that this is our hypotenuse, and we can from the angle of 34 degrees, we can see that the distance from Durban Airport to Umhlanga would be the adjacent side in this triangle. And the one that we are looking for from the angle of 34 degrees, which is the height above the ground, would be the opposite side. So therefore, working with the information that you are given, we are interested in the ratio opposite over hypotenuse, which would be the ratio for sine. So therefore, I can say sine of 34 degrees is the opposite, which is the height, all over the hypotenuse, which is 20 k's. And therefore, in order to work out the height, I just need to multiply both sides by 20. So I get the height as 20 times sine 34. We can put that into our calculator, so it's 20 times sine 34, and that will give us an answer of 11,184 if we round up to 3 decimal places. And this is going to be in kilometers, since originally our distance was given in kilometers. Now the next part of the question would like us to work out the distance, which is the horizontal distance between Durban International Airport and Umhlanga. So they would like us to work out this distance. Okay, so what we should in fact do is not round off the answer as we use it in the next part of the question. So we're not going to round it off when we use it in the next part of the question. Now there's two ways you can do this. The one way is to use your trig ratio of cos to help you to work it out, or you can use Pythagoras. So we are going to opt for the easier option here, which is working with Pythagoras to work out the distance. So the distance, if we name this DUH, we are looking for the distance DU. So therefore, by Pythagoras, we can say DH squared is equal to DU squared plus HU squared. So DH squared is equal to DU squared plus HU squared. Remember, the side we are looking for is a shorter side, therefore I have to subtract it from the hypotenuse. So therefore, du squared would be dh squared, which was given as 20 k's. Remember, the hypotenuse is always the longest side in your 90-degree triangle, minus hu squared, which we said we are not going to round off. We're going to use it as it appears on the calculator. So using our calculator, we can say du squared is 20 squared minus the answer that we just had, all squared. And that will give us 274,92. Once again, we're not going to round that off. We're going to keep it as it is on the calculator. And in order to work out du, we have to square root both sides. So we find the square root of that answer. And our answer here would be 16,581 kilometers, correct to 3 decimal places. So guys, we're going to have a look at one last example where we can use trig to help us solve real life problems. This is the example at the top of page 89. A tower that's 212 meters tall casts a shadow 90 meters long. Determine the angle to 1 decimal place that the sun's rays make with the ground. So the first step is to get all of this information into a triangle. We know that the length of the tower is 212 meters. Remember what I said to you at the beginning of this lesson, whenever you have buildings and towers and that, they're always perpendicular to the ground, so therefore we know that the angle it makes with the ground is 90 degrees. We are told that the shadow it casts is 90 meters, so that's on the ground, it casts a shadow of 90 meters. And we are asked to determine the angle that the sun's ray makes with the ground. So in other words, we want to know what is this angle here, theta. Alright, so what we've got, we're looking for theta, we've got the length of the tower, and we've got the length of the shadow. So in this triangle, if we call it triangle PQR, then if angle Q is 90 degrees, PR would be the hypotenuse. The side opposite theta, which is the length of the tower, would be our opposite side, and then the length of the shadow would be the adjacent side. So we are given the opposite side and the adjacent side. So straight away you should realize that that means that the ratio we are working with is tan. So therefore we can say tan of theta is equal to the opposite side, which is 212, over the adjacent side, which is 90. And in order to work out the value of theta, remember whenever you're trying to work out an angle, you start with the shift button on your calculator. So we say shift. Here our ratio is tan, so it's shift tan of 212 divided by 90. So this will give us an answer of 67 degrees, correct to 1 decimal place. And so therefore we can see that the angle that is made, that they would like us to work out, which is the angle made between the sun's rays and the ground, has a value of 67 degrees. Guys, and that concludes the examples where we can use Trig to help us work out real life problems. You will come across problems like this in the activities, so please make sure you understand how to do them.